So this video is the final video of the basics for integration. Otherwise, I'll be going into more detailed integration topics like Riemann sum, and also I'll be going over improper integrals and all of those ones. So don't worry, there'll be even more integrals. Obviously, this is just not just it. These are just techniques in order to easily solve integrals. But they're still a little bit tricky, especially this one here. Hey, you see, it's always the last one, man. That's always the trickiest. That is why I always leave it for last. So these are the questions I'm going to be going over in this video. Please pay attention to the timestamps that are on the whole video, and you'll see example 1, 2, 3, and 4. They are in that order. Just note that it's going to be 1, 2, 3, and 4 as follows, and that is the order that it's going to be in. Otherwise, let's just get straight into the introduction of integration by parts. Okay, so here are the formula for integration by parts. Now, first of all, let's just explain what's going on here. This is an indefinite integral, right? And then this is a definite integral. Okay, so that is the difference between the two of these, right? Because you can clearly see that this has a upper and lower limit, right? Now, let's just look at this quickly, okay? So, with this one, with the indefinite integral, that is very skew. With the indefinite integral, and both indefinite and definite integrals, what we are actually going to mainly focus on is the substitution. And to find out what is u, what is dv, what is v, and what is du. Okay. And obviously with this one, we already know from this and this over here. Okay. Great. Now because of that, this is what we're going to do. The first thing we're really focusing on first is what is u and what is dv. So that's where our substitution goes in. We're first going to find an equation for u, or we're going to find an equation with u as the subject of the formula, and then we're going to find dv. And what happens with u? U will just become du, which is equal to, let's say for example we have x, right? And then therefore the derivative of x with respect to x is just 1 dx, right? So it'll just be 1 dx like this, which is just equal to dx. And when it comes to dv, in order to go back from dv to v, first of all, we need to find the integral, right, of whatever. Let's say for example we have let's say sine x, right? Or let's say cosine x, right? Let's say that we let dv equal to cosine x, and this has to be with respect to x, because obviously we do have dv on the other side. And then therefore v will just be equal to the integral of cosine x dx. We're just adding the integral because we want to get rid of this dv and turn it into v, the original one. And then therefore what this will look like over here, it'll be v is equal to sine of x plus c. But you would see how in the when we are doing the substitution, we wouldn't really add the plus c yet until the end of the question. Okay, and it works the same with the integrals, with the definite integrals, which is why I'm going to do this one first, and then we're going to move to the more trickier ones, because the trickiest ones that I have is indefinite integrals. And you'll see with this introduction that I've just done right now, you'll see that we're going to be using this method a lot. And what do you notice here? First of all, we have u, we have v, we have du, and we have dv, which is basically all a part of this equation here, for both these equations right here. Okay, so let's move to the first example, and let's see how we apply integration by parts. Okay, so for this first one over here, what do we have? We have the integral with the lower limit 0 and the upper limit of pi over 2 is with the integrand of x multiplied by cosine x with respect to x. So that's what we have right now. Okay. So now, remember in the introduction when I said that we need to assign new variables, which is u and dv. Now, basically what's going to go on over here, we need to take the more simpler one that we can actually integrate. But I think one recommended one to do is to let u equal to x, right? Because remember, the u is for the differentiation, and the dv is for the integration. See, so that means the reason why I'm saying that we need to let u equal to x is the following, right? Let's say that we say that u is equal to x, and we take the derivative. Du will just be equal to 1 dx, or we can just write it as dx. But as you can see, du is equal to dx. I mean, we can just completely substitute dx over here. Okay. Well, that's not really our biggest issue, but we can see that it's actually easier. Okay. So now, from here, we can actually also assign something else. Now, over here, we can assign dv, which is equal to cosine x with respect to x. Now you can see why I'm including the respect to x, because you can see x is represented by u, and then this cosine x with respect to x is represented by dv. Okay, such that we have something here. Can you see that we're basically getting this form over here? Or it's actually mainly this one over here, because remember, this is a definite integral. So we're focusing more on this one here for this question. So u and dv we already found. So that means we can actually, but we haven't found dv. We haven't found v yet, because we need to also plug it into this one here. So we need to find v first. And how do we find v? We have to take the integral of the right-hand side, cosine x with respect to x. Therefore, v is equal to positive sine x, and it would be plus c, but for now, we're not going to write plus c because it's our substitution for now. Our plus c goes all the way at the end of the final answer. Okay. Great. Now, what we're going to do over here is, what I'm going to do over here is I'm just going to move this a little bit to the side here, like this. There we go. So there's all of our variables like that, right? So now we have this in the form of this, basically, this definite integral there. And because of that, we can actually now substitute all of our variables into the right-hand side. So we can write out, this is going to be equal to the right-hand side, but we need to sub in our variables, meaning that we're going to have the bracket represented here. So we're going to start with that one. U is equal to x multiplied by v, which is equal to sine x. So it'll be x times sine x. And then we'll have the upper limit, which is pi over 2, and then the lower limit, which is 0. And note that we're not actually we're not doing any substitution to find a new limit. The reason why is because, note that obviously this is the x limit, and this is also the x limit, right? But this equation is still in terms of x, meaning that we can keep these limits the same. We don't have to change anything. That's the best part about integration by parts, is that we don't have to do extra work. So this would be minus, represented over here by the subtraction sign, and then we're going to say the integral of v times du. So it's going to be the integral of v, which is equal to, no, that's not the wrong v. V is equal to sine x, and then du, is equal to dx. So we can just replace it like that. And look at that, that's perfect. We can actually just do this integral straight away. But remember, this is the integral with pi over 2 as the upper limit and 0 as the lower limit. Okay. Now we can do the following, right? And this is better known as my method here. Well, I mean, first let's just integrate this before we actually move on to the evaluation. So we're going to have x multiplied by sine of x, and then the upper limit is pi over 2, and then the lower limit is 0, minus, and then we're going to just integrate this. The integral of sine of x is equal to negative cosine of x, and then we're going to have pi over 2. And then 0, like that. Okay. We don't have to add plus c because it's a definite integral. Okay. I just remembered for this explanation here, we don't have to say plus c because, once again, it's a definite integral. Great. Now I'm going to assign different colors. I don't think you can do that in the examination, but I'm actually doing this just to show you that we can actually just do them one by one, right? We can still get the final answer. This side will be red, and this side over here will be blue. And then note how we are going to subtract the left and the red and the blue respectively at the end. So let's start with the red. We're going to do this. It's going to be, we're first going to be dealing with the pi over 2. So it's going to be pi over 2 multiplied by sine of pi over 2, right? Minus, and now we're going to be dealing with the 0 over here, which is the lower limit. Okay, so then we're going to have 0 multiplied by sine of 0. Okay, There we go. That's the red part. And then let's just finish off over here. We know that all of this is going to be equal to 0. And then over here, this thing over here is equal to 1. Sine of pi over 2 is equal to 1. Therefore, our final answer is pi over 2. Okay. So we have pi over 2 for the red. Now for the blue, I'm going to write my blue over here. We're going to have minus cosine, which is basically this whole bracket inside. It's minus cosine of pi over 2. And this is going to be minus, and it's going to be negative cosine of 0. Okay, like that. And we know that cosine of pi over 2 is equal to 0, so this is negative 0, and the negative and a negative gives a positive, and then cosine of 0 is equal to 1. And therefore, the answer here is equal to 1. Okay, so then, because we already know our blue and our red numbers, we need to subtract them by each other. So it's going to look like this. It's going to be equal to pi over 2 minus 1, which is just going to give us an answer. If we want to simplify it even more, it's going to be pi over 2 minus 2 over 2, which is equal to pi minus 2 over 2. So there's our final answer for number 1. Let's move on to the next one. Okay, so for this one, we have a rational function over here, or a rational integrand. We have ln x over x squared. Now, first of all, we need to rewrite this into a product because it makes it easier. Now, I just want to let you know that it works for quotients and products with this integration by parts. But you would rather want to write it as a product because it actually follows this one right here, where this is the product of u and dv. Okay. So therefore, it'll just be equal to the integral of, let's just say, ln x multiplied by x to the power of negative 2. Okay, with respect to x, like that. Now, which variables are we going to assign what? First of all, the integral of ln x. Well, I mean, that's when if you want to assign, so let's just do this, right? What are we going to assign for u and what are we going to assign for dv? Now, first of all, whenever we deal with dv, we're going to work with the integral, right? Meaning we have to work with the integral of ln x with respect to x, right? But even you even have to use like the integration by parts to actually determine the integral of ln x. So that's why I don't recommend finding the integral of ln x now with dv, but rather find the integral of x to the power of negative 2 with respect to x rather, because it's easier that way. Otherwise, this one is going to require you to do integration by parts again, but it's going to be more complicated. So like I say, you need to careful which variable you are assigning. And this is when you're actually going to, in your question paper, rather see, like maybe foreshadow what your answer would be if you assign different variables. Okay. Then we're going to let u equal to ln x. Okay. So now we've done with, we dealt with ln x, and we've dealt with x to the power of negative 2 with respect to x. We've done that already. Okay. Now we just need to differentiate and integrate. Let's just move this here quickly downwards. We're going to differentiate over here. We're going to have du is equal to, what is the derivative of ln x? The derivative of ln x is equal to 1 over x with respect to x. Okay. And over here, we could, okay, let's just keep it as 1 over x for now. Okay. So over here, we are going to have, to find v, we're going to have to take the integral of x to the power of negative 2 with respect to x. And note how we can actually immediately do that. We can actually do this. This is going to be v is equal to, and it's going to be x to the power of negative 2 plus 1, which is actually equal to negative 1, divided by negative 1, right? But obviously we can just write it as negative x to the power of 1, negative 1. With not with respect to x, it is plus c. But obviously, once again, it's a substitution. We don't say plus c yet, only for our final answer. Okay. So over here, we have what we actually have u, we have du, we have v, and we have dv. Perfect. And this fits our indefinite integral over here. Okay. Great. Now, what we have to do is we just need to plug in. Okay. So I'm just going to move this out of the way because this is always in the way. I should actually just start writing them right underneath, actually. It's actually crazy how I just find the worst possible spots to do my work. Okay. Now that we found those variables, right, in terms of x, we can actually start using the integration by parts, right? Because what we can see over here, we have ln x, which is actually represented by u, right? And we have x to the power of negative 2 represented by dv, which is shown over here in this work there. Therefore, we can use the integration by parts. Okay. Great. Now, we're just going to basically substitute our variables in terms of x. We're going to have u multiplied by v, where we know u is equal to ln x, multiplied by v, which is equal to, we can actually write this as negative 1 over x, right? Because it's negative x to the power of negative 1, which can also be written as negative 1 over x. This is minus the integral of, it's going to be v multiplied by du. What is v? V is equal to negative 1 over x. We can write that as well again. And then this is just going to be written as, what is du equal to? Du is equal to 1 over x with respect to x, like that. Great. Now we just need to make it easier to read. Well, I mean, now we can actually take this negative to the front. So it's going to be negative natural log of x multiplied by 1 over x, like that. And then this negative can go outside of this integral, and then this will become a positive, and we'll have integral of 1 over x squared with respect to x, but we can also write this as x to the power of negative 2. Note that I'm doing this so that we can actually integrate properly. Okay. Now that we can actually integrate, we can do the following. We can say this is negative ln x multiplied by 1 over x. This is plus, and then the derivative of, the integral of x to the power of negative 2 with respect to x is just going to be, remember we actually already did this, right? We did it right here. So that means we can just say that's equal to negative x to the power of negative 1 plus c. Because we already just took the last integral that we had. Okay, so it's plus c. So now we can just write this in simple terms over here. We can just write this as negative natural log of x. So I actually want to write the 1 over x in front here just to show you what's going to happen, right? Natural log of x, and this is going to be minus 1 over x plus c. And then note how we can actually take out negative 1 over x as a common factor, and if we do that, we're going to have negative 1 over x into ln of x plus, minus 1, so it's going to be plus 1 because it's negatives, it'll all become positive, plus c. And that is our final answer for question 2. Let's move on to the next one. So number 3, it says the integral of x squared multiplied by cosine x with respect to x. How are we going to assign our variables now? So note now we're going to let u be equal to something and dv be equal to something else, right? Let's focus on u first. Well, if we take the integral of x squared, normally what I do, I always look at which one is the most complicated to take the integral of. Well, clearly x squared is a little bit more complicated because the integral of x squared will just be equal to, I believe, 1 over 3 u to the power, not u to the power of, it's x to the power of 3, right? Which is a little bit more complicated than just taking the integral of cosine, which is just sine x, right? Plus c. So that is why I always recommend just looking at what you're going to be taking the integral of. Okay, which one is more complicated? So therefore, it's more simple to take the derivative of x squared than to take the integral of x squared. Therefore, if we were to take the derivative of x squared, it will be du is equal to 2x with respect to x. Okay, great. And now, because we got du, we have u and du, now we need to find dv and v. So dv, we're going to assign to cosine x with respect to x. So cosine x with respect to x, and then we are going to take the integral in order to find v. So v will be the integral of cosine x with respect to x, and then therefore v will just be equal to sine of x plus c, but it's the substitution. So we're going to have sine of x. Now here's what we're going to be doing, and I think this was a little bit more complicated, but it's fine. We're going to go through this together here. Now that we have x squared, which is represented by u, and then cosine x dx, which is represented by dv, we can actually use the right hand side of this equation now. Okay, so we're going to substitute all of our variables. Therefore, it'll be u times v. U is equal to x squared, and v is equal to sine x minus the integral of, it's going to be v multiplied by du. V is equal to sine x, and then du is equal to 2x, so it's multiplied by 2x with respect to x. Okay, and then let's just take the constant out, like so. So we're going to take the constant out. We're going to have x squared sine of x minus 2 integral of sine, or we're going to write it as x times sine x with respect to x. Okay, now it looks a little bit better to integrate. But notice something. We have a product of two functions, right? Of two variables. We have a trigonometric function, and we just have x over there. Meaning that we have to do the integration of parts once again. Okay, so we have to do it again. But this time we're going to assign newer variables. That still falls under the line of this formula. So basically the new formula that I'm going to be creating is going to be as follows, right? I'm going to write it in blue rather. So we're going to have the integral of u with respect to v is going to be equal, oh no, the integral of w with respect to z, it's just two new variables, it's w and z, is equal to w multiplied by z minus the integral of z with respect to w. Note that I've just replaced everything, I've replaced every single u with w and every single v with z. Okay, that's exactly what I just done. So therefore, if we were to do integration by parts, w will be the differentiation one, and then the dz will be the integral. Okay, so we're gonna let w, in our case over here, it would actually be easier to let w be equal to x. See, it's better to find, so it's better to differentiate x, and then it's also better to integrate what we had to be. Sorry, I was talking about this x, by the way. And then sine x over here with respect to dx, we're going to make that the integral. Okay, we're going to find the integral of that. So this would be dw is equal to 1 with respect to x, like that. Or it can just be equal to dx. It doesn't matter. Okay, I'll just keep the 1 there for now. And then over here, we need to use dz, which is equal to, and we're going to have sine x with respect to x, exactly what we just had here, right here. And then over here, we are just going to, in order to find z, we're going to take the integral of sine x with respect to x, and therefore z will be equal to negative cosine of x. Plus c, once again, plus c is not going to be there. Okay. Now we can just sub into our new equation that we've made. But it's the same equation, but it's just the variables are flipped, basically. It's different variables. So that's what we're going to be doing. We're going to do this now. This is going to be equal to x squared sine of x minus 2. And remember, this, everything over here, from the integral to the dx, that is what we've changed. So we're going to put a bracket here. Therefore, this is going to be written as, it's going to be wz, w multiplied by z, w is equal to x, and z is equal to sine x. Or no, z is actually equal to minus cosine x. Okay, minus cosine x. And then we're going to say minus the integral of, and then we're going to have z multiplied by dw over here. So z multiplied by dw, z is equal to negative cosine x. So negative cosine x multiplied by dw, which is equal to dx. 1 dx, but we can just write it as dx. Okay, and then close the bracket. And now what we can do, we can actually just write it in simpler terms over here, where we're going to have the x squared sine x minus 2 into, and then we can just write the negative here because we're going to take the negative outside there, x cosine x. And this is going to be, the negative comes out like this. It's going to become a positive. So it's going to be positive integral of cosine of x with respect to x. Close the bracket. And now I would recommend this. Take this negative 2 into the, so take this negative 2 into both of these terms in the bracket. And therefore we're going to have x squared sine x. It's going to be positive 2x multiplied by cosine of x. and it's going to be minus 2 into the integral of cosine x dx. Okay, so that's what we have right now. Great. Now, from here, we can actually just take the integral of this, of cosine x with respect to x. It's easier now. Do you see that? So therefore over here, this is going to be equal to x squared sine x plus, and it's going to be 2x cosine x, and note we can actually write it in one line so it looks better now, minus 2, and then bracket, we're just going to integrate this over here. The integral of cosine x is just equal to positive sine x. Okay, and then this is plus c at the end because we took the last integral. Okay, and then therefore what we are left with is x squared sine x plus 2x cosine of x minus 2 sine of x plus c. And if you want to simplify even further or factorize even further, look at this. We have x squared multiplied by sine x minus 2 sine of x plus 2x cosine x plus c, and then note that sine x is a common factor of these two terms. So therefore we can take out sine x as a common factor, so it will be sine x into x squared minus 2 plus 2x cosine x plus c. And there is our final answer for this integral. Let's move on to the last one. Okay, so this is the final one. This is more of a higher order question, by the way. It's nothing different. It's still integration by parts, but there is a little bit of a trick at the end, which I did come across when I was doing the question myself. This one was a very crazy one, but let's just go through this together. Okay, so first of all, we need to assign our variables, right? So first of all, over here, we are going to just take note, which one are we going to integrate? Well, it would be nice if we integrated sine x with respect to dx, but I think it would have been easier to integrate e to the x, because let's just remember that the derivative of e to the power of x is just equal to e to the x, meaning the antiderivative is also going to be e to the x, but e to the x plus c. So basically what I'm saying is the the integral of e to the x with respect to x will also be equal to e to the x, but plus c. Okay, so that's what I'm saying. It's the same thing. That's why it's so much easier to use the integral of e to the x. Okay, so that's what we're going to be doing. We're going to let u equal to sine x, or let's just rewrite it like this so it's easier for us to understand this. It's going to be, we're going to rewrite it as sine x multiplied by e to the x with respect to dx, meaning that u is going to be equal to sine x, and then dv is going to be equal to e to the x with respect to x. So this is how we're going to write it. U is equal to sine of x, and if we find the derivative, so it's going to be du is equal to negative cosine of x with respect to x. Okay. Oh no, sorry, that's the wrong one. I was thinking about the integral. You see, this thing's ruining me. It's going to be positive cosine x with respect to x, like that. Okay. Now we need to let dv equal to e to the power of x with respect to x. So dv is equal to e to the power of x with respect to x, and then basically to find v, we need to determine the integral of e to the x with respect to x, and I just said that the integral of e to the power of x with respect to x is just e to the power of x plus c, but it's in a substitution. So let's not say plus c yet. Perfect. We found u, we found du, we found dv, and we found v. That's exactly what we need in order to use this now. And we can see this is in the form of, it's going to be u multiplied by dv. That's exactly what we have, so therefore we can use the right hand side of this equation. Okay. Great. And now this is how it's going to be written. U multiplied by v, so we know u is equal to sine of x, multiplied by v, which is equal to e to the power of x, minus the integral of v, which is equal to e to the power of x, with respect to, multiplied by du, du is equal to cosine dx. Oh my goodness. Look at that. The hell is this? What are we going to do with that? Well, integration by parts once again. I know, that's unfortunate and it's very tragic that we have to do integration by parts again. Man, this is getting ridiculous. What do you think? Now I'm kidding. This is actually really cool. So check this out, right? So we're gonna have we need to assign new variables, right? And because it's not a definite integral, it makes our lives much easier. Meaning we don't need to deal with like values. We can just deal with variables. Okay. So from here, we can actually just do the following. We need to assign new variables, and if you remember from the last example, I assigned w and z, right? So that means we're going to let w be equal to something, and it's just easier. Once again, it's really easier to, and I forgot about this, by the way. It's really much easier to just take cosine of x to be the derivative part and e to the x to be the integral part, because obviously the integral of e to the x is just e to the x. That is why it's just better to do that. Okay. So we're going to let w be equal to cosine of x. Therefore, the derivative is going to be equal to, so it's dw is equal to negative sine, there's the negative, x with respect to x. Okay. That's what we have. Great. And now dz, remember these are our new variables from the last question. If you want to look at the last question of how we assigned it for the first time, go for it. If you didn't check it, if you just skip to the last one, because I think a lot of you people want to actually see this last question here. Maybe you came across it in your papers. Okay. dz, we're going to let it equal to e to the power of x with respect to x, right? So it's going to be e to the power of x with respect to x. And then in order to find z, we find the integral of e to the power of x with respect to x. Okay. And then therefore, z is going to be equal to e to the power of x, just e to the power of x for now. Okay. So now we found w, we found dw, dz, and z. Perfect. Now we can just plug it into our equation. And it goes in this format. It's going to be w multiplied by z. But first of all, remember, we're only doing integration by parts with this integral here, and not this over here. This stays the same. So we're going to just write this one down quickly. It's going to be sine x multiplied by e to the power of x minus, and it's going to be, this is where the integral takes place. So it's going to be u multiplied by w. We know that, or w multiplied by z, sorry, my fault. It's going to be cosine of x multiplied by e to the power of x minus, I'm just going to write the minus here rather, the integral of, it's going to be z multiplied by dw. So z is equal to e to the power of x multiplied by dw, which is equal to negative sine of x with respect to x. Okay, so that's what we have, and then close the bracket. And hey, you're already going to see, do we need to do integration by parts over here? This is exactly what we're going to do together over here. But let's just continue, right? We're going to simplify it further. We're going to have sine of x multiplied by e to the x, and then over here we're just going to take the, okay, let's just first focus on the inside. First, simplify the inside. It's going to be cosine of e to the x, sorry, it's going to be cosine of x multiplied by e to the x, and because this negative is over here, we can actually take this negative out, and then it'll become positive. So it'll be positive integral of e to the power of x multiplied by sine of x with respect to x. Alright, and now we're going to take the negative into the bracket. So it's going to be sine of x. So let me actually write it here so we have more space. So it'll look like this. It's going to be equal to sine of x, well, I rather, yeah, no, that's fine. Let's just do this. Sine of x multiplied by e to the power of x minus cosine of x multiplied by e to the power of x plus, oh, sorry, it's going to be minus, yeah, sorry, because it's negative and then positive gives a negative. So it's going to be minus the integral of e to the power of x multiplied by sine of x with respect to x. Okay. So here's the issue, right? If we do take the, if we do integration by parts again with new variables, we're still going to have to do integration by parts. It's going to be an infinite loop, right? But let's just take into consideration that we always have been doing this equal sign the whole time, because obviously we are too lazy to write this down all the time. And this is where they're trying to catch us out in this question. We are so lazy to even write down this expression every single time on the left hand side, because we always just write equals to and then we follow the same trajectory. But let's just do that quickly. We're going to write this, right? We know that the integral of e to the power of x, I'm going to try and write it a little smaller, multiplied by sine x with respect to x, that is exactly what we had in the beginning, is actually equal to what we have right now. Do you notice that? Because of that equal sign, we've literally been doing this entire time. So this is what we have. Now that we have it like this, also, sorry, I should have actually done this. I should have copied it and then pasted it, because that would be weird just to have it gone like that. Okay. Now this, I'm pretty sure you can see what we're going to be doing. What do you notice here? This is the same as this. That is perfect. That is exactly what is going to... This is what makes this question so amazing. Now, let's just do this, right? We want to eliminate this because this is such a problem to us right now. Because it's going to constantly become integration by parts all the time. And we're just going to do it infinite amount of times. So in order to eliminate that, let's add both sides by exactly what this is, so that we can basically cancel it out. So what is it going to look like? And I'm going to write it a little bit smaller. We're going to have the integral of e to the power of x multiplied by sine of x with respect to dx, plus the integral of e to the power of x multiplied by sine x with respect to x, which is equal to, and note how these can actually add each other, and it will give you 2 integral of that, basically, because the constants are 1. But we'll get into that now. Okay. Which is equal to sine of x. Wait, let me just write the e to the x over here because it looks better. E to the x multiplied by sine of x minus e to the x multiplied by cosine of x. I'm actually going to write it over here. This is going to be minus the integral of e to the x multiplied by sine of x with respect to x. And remember, because we added this to the equation on both sides, we need to add it on this side as well. Okay. Plus the integral of e to the x multiplied by sine of x with respect to x. Perfect stuff. Guess what? These can cancel now. And then guess what? Over here, because these are exactly the same, the constants will just add each other. Meaning we will have 2 into the integral of e to the power of x multiplied by sine of x with respect to x. Which this is just going to be equal to whatever is left. What we cancelled out is just gone. We just left with that. E to the power of x multiplied by sine of x minus e to the power of x multiplied by cosine of x. Okay. And then note that we want to actually get this on its own. Remember that we are actually trying to determine this integral without the 2, obviously. Because the initial question was exactly that. And it is an equation where we want to find that. So therefore we have to divide both sides by 2. And then we'll get the integral of e to the power of x multiplied by sine of x with respect to x multiplied by a half, right? We can just multiply a half on both sides, and then therefore this will cancel, obviously. That's what we said already, or divide both sides by 2. And what do we notice here? E to the x is a common factor. So we can take out e to the x, but we can also divide this by 2. And this is multiplied by, or you know what, let's just make it a little bit simpler here. I'm going to keep the 2 here for now. I'm actually going to take out e to the x as a common factor just for now. Right, so we can take out e to the x as a common factor. This is sine of x minus cosine of x. And then now we can divide both sides by 2. Then we'll have the integral of e to the x multiplied by sine of x with respect to x is equal to e to the power of x divided by 2. Multiplied by sine of x minus cosine of x. Obviously, instead of writing them divided by 2 over here, you could have actually divided this entire part by 2, and you could have excluded the 2 from there. Okay, but this is the final answer. Very tricky, eh?